Hello everyone, Mr. Minnick is my name, math is my game, and today in Algebra 2, we're going to answer a question that Algebra 2 students need to really know all the answers to when it comes to the next section in our book. We're getting ready to complete the square, and before you can do the idea of completing the square, you really need to be able to answer these questions about perfect square trinomials. And as we proceed with the notes today, we're just going to take each one of these bullet points and examine them one by one. It'll be like a subheading for each little section. So the general question, what is a perfect square trinomial, has several questions that, like follow-up questions, more specific to the nature of them. What is their general form? We've seen that, and we'll take a look at it. And there's actually two general forms. When we look at the general form, we'll also be answering the question, how do they factor? Because that's what the general form will answer. So that those two items there should be on the same page when we get to that. And then we're going to back it up, and we're going to compare and contrast. And I asked my students to do this on a test last week, or a couple weeks ago now. I missed a week. But we're going to ask, what's the difference between a perfect square trinomial and a difference of two squares? And probably the hardest thing that we're going to look at today, the most difficult thing, the most challenging thing, and this is going to get us ready for the heart and soul of this lesson, is the relationship between the middle term and the first and last terms. That is what we really need to understand firmly to be able to complete the square, which is what chapter 4 section 6 in the Algebra 2 text is all about. How does the middle term relate to the first and last terms? And finally, last but certainly not least, when we factor a perfect square trinomial, there's something special. There's something special about what it factors into. When you factor a perfect square trinomial, there's something special about what they factor into. And so we're going to answer that question. What's so special about that? So hopefully in today's lesson, we'll be able to get a sneak peek into what we're going to look at Thursday, a sneak peek into what we're going to look at on Wednesday as well. Okay, so perfect square trinomials. What's their general form? How do they factor? What's the difference between a perfect square trinomial and a difference of two squares? The relationship between the middle term and the first and last terms, and what's so special about what they factor into. And I'm kind of disappointed in myself with that fifth bullet point there. Any grammar majors, any English majors know why I'm disappointed in myself? What's wrong with that? Yeah. What is could be what. That's not so bad. Contractions are optional. That's not why. I don't think a math or an English teacher would knock that. There's a certain way you're not supposed to end a sentence. There's a certain form of speech. Aren't you not supposed to end a sentence with a preposition? But it gets wordy. What is so special about what they factor into? I should have said, what is so special about that which they factor about, I don't know. I don't even know how to say it without ending it in a preposition. Anyway, that's a little side note, not relevant. So here we go. What is their general form and how do they factor? What is their general form and how do they factor? So we'll go ahead and address this right now. We've seen this. Some of you have written this down in your notes probably twice by now. Some of you might not have written this in your notes, but regardless, it's a good idea. And I'm just dropping my marker. Every morning so far this week, I've dropped something. Yesterday, I had a Sensi burner. You know, the little mini Sensi burners. I went to take it over to the trash can and pop the wax out, and I cracked it, dropped it, broken it into hundreds of pieces. All right, so the general form of one of these things is a squared plus 2ab plus b squared. That's one of the general forms. The other general form is real similar to that. It's a squared minus 2ab plus b squared. Okay, so if you compare those two forms, it may seem obvious, but there's somebody out there that doesn't see it. What's the difference between those two forms? Anybody? One's adding 2ab and one's subtracting 2ab, right? So a couple things to point out, a couple things worth noticing. In the one form, we've got a plus here and a minus here in the other form, right? Another thing to notice is that this last term is always being added, okay? Might seem kind of, well, yeah, duh, but you need to realize that that last term is always going to be plus something, okay? All right. So when we factor these things, what these factor into, so this is the general form here on the left, the general form, and this is what they factor into. So on the right, we should remember this from a few sections ago. This factors into a plus b, the quantity squared. And then this other one, this red one, it factors into a minus b, the quantity squared. Now, a lot of people have trust issues. I know I do. I really have trust issues. I don't trust many people. When I was 15 years old, kind of a long story, but a true one nonetheless, I was really good at cross country. I ran cross country as a freshman. Actually, I'll back that up. As an 8th grader, I ran JV high school races. My 7th grade year, they let me run a JV high school race, and I ran like a 19-something, and I would have got 3rd place, but I wasn't allowed to finish. Anyway, so high school, my sophomore year in high school, I was running low 17 5Ks. Our team had a great chance to go to state. In the morning of the regionals meet, I was hanging out with my friend. He had to follow, it's a long story, but anyway, he had to follow his dad somewhere. We're in this van. He asked me, he said, "Hey, Matt, how's traffic?" I said, "Well, it's good after this truck." So there's a big dually truck coming on 422, and he punched it. He tried to cross 422. With a dually truck coming at us. That truck was going 70. We were in a Ford Econoline van. The van rotated 270 degrees, did a complete 360 flip. I was in the passenger seat. I landed in the back seat on the doors of a 57 Chevy, and I bent the doors of a 57 Chevy. Yeah, that's how hard I landed in the back. Anyway, I didn't have a seatbelt on. I got a seatbelt ticket out of the deal. I was mad. The EMTs showed up. They said, "Are you all right?" I said, "I need to run in about 2 hours. I'm fine. I just need something to drink." "Oh, you're not allowed to drink anything." I said, "Listen, I'm hydrating. I'm about to run regionals cross country. I need something to drink." Anyway, from that point on, I had trust issues. I don't like to ride in a car with anybody else driving. There's only about 3 people that I'll ride in the car with. So, anyways, traumatic events like that will change your outlook on things. Eventually, it gets a little less whatever. But so I have trust issues, and I know you do too. And I know a lot of times if you see something like this, you're going to be like, "But that can't factor. It doesn't factor." Let's look at 16x squared. 16x squared plus 40x plus 25. Okay. That is a perfect square trinomial. A lot of people are like, "Well, how do you know?" Well, we'll address that in a little bit. The relationship between the middle term and the first and last terms, that's really how you can tell if it is a perfect square trinomial for sure. Couple quick things you can look at. Is that a perfect square? Is 16x squared a perfect square? Is 25 a perfect square? Is this a plus? Okay, so it looks to be a perfect square trinomial, and I'm telling you that it is. And because it is, we can factor this, and we know the form's going to be something squared. We know that. We should trust that. Okay, whether we want to or not, we should trust that. So in this form then, to go from the first term to the first term, how does a squared compare to a? Well, we just take the square root, right? So same idea, to go from our first term to our first term, 16x squared to whatever this is, we're just going to take the square root. So what's going to be that first term? 4x, good. So that first term then is just going to be 4x. Pretty easy. Not so bad. Trying to find my mint toothpaste colored marker. Have no idea where it went. There it is. So that first term is going to be 4x squared. Right? Oh, not 4x squared. I'm sorry, that's a neck. 4. Oh man, this is a mess. That's just 4. Now nothing's working. The eraser's not working. Oh man. It's going to be a long day, I tell you what. 4x. Doing all right? Okay. So again, looking at the form, to go from the second term to the second term, b squared to b, again, we just take a square root, right? We just take a square root. So back here, to go from the last term to the last term, we just take a square root. And everybody knows the square root of 25. It's 5, right? So it's going to be a 5 there. And then we got one more thing to figure out. We got to figure out our sign. And if we look at the forms, whenever the sign's positive, the sign's positive. So the sign's positive, so the sign in the middle is going to have to be positive, right? Now, I know what some people are thinking. They're thinking, but 4x plus 5, the quantity squared, isn't equal to the thing above, and it has to FOIL out. Because I know what you're thinking, and I'm going to write this in magic marker, and don't write this down, but watch this. People think, well, 4x plus 5 squared is 4x squared plus 25. They don't know how to multiply. Or they think, okay, well, 4x plus 5 squared would be 16x squared plus 25. Again, they don't know how to multiply. This exponent of 2 here, you know what that means, don't you? It means that quantity has to be squared. It's 4x plus 5 times 4x plus 5, which would be 16x squared plus 20x plus 20 more, oh man, I knew that was going to happen, plus 20 more x plus 25, and this will make the 40x, and it is what it is, okay? Just trust the pattern. It works. It works, okay? We good with that? All right. So what is their general form? Here you go. There's a squared plus 2ab plus b squared equals a plus b quantity squared. A squared minus 2ab plus b squared equals a minus b quantity squared. Okay. So I think we answered the yellow highlighted items, huh? Are there any questions before we move on? Any questions at all before we go to the difference between a PST and a D2S? Okay. I don't want to spend too much time on this next one, but we will look at it, because you know what they say. Sometimes you've just got to look at it. So if we can compare and contrast these, I really like to use these triangles when I compare and contrast these. You don't have to use these, but for me it just makes a nice visual reference. So if we're looking at a difference of 2 squares, a D2S if you would, a difference of 2 squares is characterized by having a minus in the middle of 2 things, of 2 perfect squares. And on the test, some people said that. They said, well, a difference of 2 squares has 2 terms in it, and they're right. A difference of 2 squares does have 2 terms in it. If we look at a perfect square trinomial, because of the tri prefix, it's going to have 3 terms, and you're right about that. That's a squared minus 2ab plus b squared. Okay. Remember this this minus here, that could also be a plus. I'm just using minus just for whatever, but that could be a plus also. So at the bottom of these triangles, I'm going to put what they factor into. I want to put what they factor into. What they factor into. Or maybe I should write the factorization. The factorization down here and down here. Okay. A difference of 2 squares, when you factor that, it factors into 2 quantities, something plus and something minus. And again, just like we did before, we're just taking square roots, a and b and a and b. And when we factor a perfect square trinomial, it factors into, I probably should have made that one red. It's going to factor into a minus b, the quantity squared. So what's the difference between the two? Well, they both follow a pattern. I guess that's a similarity. They both factor. They both should factor easily. But what's the difference? Well, difference of two squares has two squares. And it's a subtraction in the middle of the two. And the last term is being subtracted. The b squared is being subtracted. Perfect square trinomial's got three terms. First term and the last term are perfect squares, and it's got a middle term, and that middle term's kind of weird. Do we feel a little bit better about our ability to answer that question? What's the difference between a PST and a difference of two squares? Okay. All right. Well, I don't know if I'm ready to answer the green question just yet. We probably ought to talk about this, because we're going to have to do that. Going to have to talk about that to answer the purple question. What's so special about what they factor into? The interesting thing about that a minus b, the quantity squared, or even a plus b, the quantity squared, the interesting thing about that is if I were to mention that, if I were to give that an acronym, some people might laugh. And it's no joke. But some people might laugh. Some people might find it comical if I say what that is or what that is. You know what those are? I better use the magic marker for this. Let's think about what that stands for. We're talking about things being squared, right? And we talked about trinomials. So a perfect square trinomial factors into one of these things. What are these things? They're binomials, aren't they? Isn't that a binomial? Two terms? And it's a binomial with an exponent of 2, so it's a binomial squared. It's a squared binomial. It's a squared binomial, binomial squared. That's what a perfect square factors into. Perfect square trinomial, I should say. A perfect square trinomial factors into a binomial squared. What's so special about perfect square trinomials? They factor into binomial squareds. What's so special about binomial squareds? Well, we'll look at that as the very last item up for bids. We're actually making pretty good progress today. I think we might finish with more than 5 minutes left. I'd like to give a shout out for everybody who's taking copious notes. Nice job. I could give a shout out for everybody who made it through the first 9 weeks and survived Algebra II. Good job. I'd like to give a shout out to Mike Jones. In case you don't know who Mike Jones is, he's a rapper. He's in my dream class. All right, so to answer that next question, that green question, we're going to have to look at a whole bunch of these. I'm going to write up several, and some will make it a lot more easy to see than others. So the question that we're going to try to answer is, what's the relationship between between the middle term and the first and last terms? So to answer this, we need to see a lot of perfect square trinomials, and in some, I'll be really honest with you, some are confusing. They don't help a bit. X squared minus 4x plus 4 is a perfect square trinomial. X squared plus 6x plus 9 is also a perfect square trinomial. X squared plus 10x plus 25 is also a perfect square trinomial. of the more challenging varieties to see the relationship between the middle term and the first and last terms, 9x squared plus 12x plus 4 is also a perfect square trinomial. More challenging is 36x squared minus 12x plus 1. That's a perfect square trinomial. And the last one I'm going to put up here, and I'm going to put an asterisk next to it, but negative 25x squared plus 70x plus 70x minus 49. That is also, even though it doesn't look like it, it is also a perfect square trinomial. So all 6 of those expressions written on the board are perfect square trinomials. If we trust the pattern, we should be able to factor all 6 of those. And we'll do that in a minute. But the question is, what's the relationship here between the middle term, between the middle term of each one of these, between the middle term of each one of these, and the first and last term, and the first and last term, and the first and last term. What's the relationship between that middle term and the first and last term? And the first and last term. That last example I've got there, it's really kind of a mess, and I'd rather just disregard that one just for a minute. Pretend as though it's not even there. Does anybody think they have an idea what's the difference or what's the relationship between that middle term and the first and last terms? What are you thinking? Okay, for the first one? So you're looking at how it would factor. Well, what we want to answer is how does that middle term relate to the first and last terms? What's that? It's something x squared. Well, maybe we better not look at this. Maybe we better not look at this one, or even this one, or even this one, or even this one. Let's just look at x squared plus 6x plus 9. Let's just look at that one. How does the middle term compare to the first and last term? Maybe we should think about the general form. Wasn't the general form a squared plus 2ab plus b squared? Wasn't that the general form? So what would happen if we were to take the square root, of a squared? And if we were to take the square root of b squared, what's the square root of a squared? A. What's the square root of b squared? B. So the first term when we take its square root is a. The last term when we take its square root is b. Now the middle term is 2ab, right? So now do you see the relationship between the first and the last term? Between the middle term and the first and last ones? What I'm going for here is if you were to take the first term and the last term and you take their square root, square root of x squared is x, square root of 9 is 3. So if we were to multiply x by 3, that'd be 3x. And then if we were to go ahead and double that, that's what that middle term is. The middle term is twice the square root of the first term times the square root of the last term. I know that's a mouthful. The middle term is twice the square root of the first term times the square root of the last term. And it could be plus or minus that. So if we uncover this first one, the square root of x squared is x, square root of 4 is 2. 2 times x times 2 would be 4x, and the middle term is 4x. If we look at this next one, 25 square root would be 5. X squared square root is x. 5x doubled is 10x. Does this make sense? now what a perfect square trinomial is, what the middle term looks like? Doing all right? Okay. So what I'd like to go ahead and do then, I know I said we would do this before we moved on, and we're almost done. We're almost done. I'd like to go ahead and factor each one of these. Go ahead and factor each one of these. So if we had to factor this this x squared minus 4x plus 4, what's that going to factor into? Anybody? An x and a 2, and it's going to be the quantity squared. X what, 2? Minus 2, the quantity squared, right? Okay. Let's go ahead and look at the next one. We'll go ahead and try to factor this. X squared plus 6x plus 9, what's that going to factor into? What's that going to factor into? Yeah. Not 3x plus 2 squared. It's going to be yeah, no, we're not on that. Oh, no, yeah, we're looking at the x squared plus 6x plus 9. Sorry. Oh, you already had the other one. Okay, I got you. I'm picking up what you're putting down. So x squared plus 6x plus 9 factors into x plus 3 quantity squared. Good. X plus 3 quantity squared. The next one, x squared plus 10x plus 25 factors into x plus 5 quantity squared. We're rolling now. Doing all right? Okay, let's go over to this other one then. This one, we had this one. This is 3x plus 2 quantity squared, right? And then looking at this 36x squared minus 12x plus 1 is going to factor into what? 6x something 1 minus 1 quantity squared. Okay? Trust the pattern. The pattern always works. Now that last one, the one that I had covered up for a while, I put an asterisk by it because it's technically not a perfect square trinomial as it sits, but you can quickly make it one. If you do what? Abracadabra, alakazam. I'd like to factor out a... I don't like leading negative. So what am I going to do? Factor out the negative. Yeah, we need to factor out a negative. That's negative the group of 25x squared minus 35x plus 49. Okay, so that negative sitting out front of that, it's one of those things I would kind of forget that it's there for a minute. I would forget that it's there for a minute, and then I'd go ahead and try to factor. And we should be able to factor this. It's going to be what? 5x minus 7, the quantity squared. And hey, there's that negative sign out front, so guess what? There's that negative sign out front. How we doing? All right? Cool beans. So I'm going to give a shameless plug to the TI InspireCast. It's that calculator that does all the things that math teachers don't want calculators to do for you. It can factor these. The yellow Inspires that we use in class won't do this. Negative 25x squared plus 70x minus 49. Factor that for the variable x. I said for the variable x. Look at that. Wow. Wouldn't that be nice to have that calculator? Okay. So I think that just leaves us with one final item up for bids, and it's purple, and that purple's hard to see. What's so special about what they factor into? So I'm just going to give you a sneak peek into a problem that you're going to see by the time we're all done with this. Solve x minus 8, the quantity squared, equals 16. Now this kind of reminds me of new guitar day. Most of you know that I own several guitars. At one point I owned about 17, including basses. Not saying that to brag, just saying that because I have an obsession. I have guitar acquisition syndrome. I need some serious help. I just bought a bass for the week that I was off. Actually, I traded my wife's piccolo in and got a new bass. With her permission. Don't worry about that. But she won't let me live that one down. She reminds me every day. So anyway, the day I get a brand new guitar, you know what I do with the guitar? Brand new one, electric guitars. I can't do this with acoustics, but with the electrics, I take them apart. Everything with a bolt and a screw and a nut that I can remove, I do. I take them apart. I make sure that the electronics are all soldered the way they're supposed to be. I make sure that all the parts fit together the way they're supposed to, and I put brand new strings on it and put it back together. It seems like a lot of work, doesn't it? But that's what I do. What also seems like a lot of work would be to go ahead and multiply this out. And do this, x squared minus 16x plus 64 equals 16. And then say x squared minus 16x. If I subtract 16, oh gosh, I hope I can figure out the difference between 64 and 16. Isn't that 48? I want to say that's 48. Right? That's a lot of work that I did so far, isn't it? Probably what would have been better is to just play the stinking thing. Just plug it into an amp and have at it, right? Well, there's nothing wrong in doing what I did so far. If I did that, I should be able to factor this into x, and the factors of 48 are that add up to 16 are 12 and 4. So if I were to do this, I would get x minus 4 is 0, x minus 12 is 0, so I would get x is 4 and x is 12. And there's nothing wrong with that, but that's kind of like me taking apart a brand new guitar, removing everything that can be removed, inspecting it, and putting it back together. There's got to be a better way. And there is. There is. Check this out. X minus 8, the quantity squared, equals 16. There's something very special about having something squared. You know what's so special about having something squared? You know what you could do to it? You know what you can do to a quantity squared? Picking up what I'm putting down? Can't we do this to a quantity squared? So what happens if I take the square root of this quantity squared? What am I going to get? In case you're not sure what I'm looking at this right here. X minus 8, the quantity squared, and I take the square root. What's that going to leave me if I take the square root of that? Thank you, x minus 8. Good. That's just going to leave me x minus 8. Now, I hope you remember that whatever you do to one side of the equation, you know what you got to do, right? The same thing to the other side. So I got to take the square root of 16. Now, what's the square root of 16? 4. Now, could it be negative 4 also? Oh, so it's plus or minus 4 then. So it's plus or minus 4, right? All right. Well, I just want to get x by itself, so all I need to do is go ahead and add 8. So x is going to equal 8 plus or minus 4. So 8 minus 4 is 4, and 8 plus 4 is 12. Is 12. Huh. Wait a minute. 4 and 12, I got those by factoring, and I could have got that by taking square. Wait a minute. This is... Of those two methods there, that taking the square root and factoring, which one do you think's faster? Taking the square root, isn't it? I think so. And that's where we're going to be heading by the time we get to Thursday. Okay, that's where we're going to be heading. The only problem is we're not going to be so lucky. We're not going to be starting out with a quantity squared. We're going to be starting out with a perfect square trinomial. Or we might not even start out with a perfect square trinomial, and we're going to have to make one, and that's what we're going to do this week. It's called completing the square, which means make a perfect square trinomial. It's been real. It's been fun. I hope it made a little bit of sense. Shout out to the future Mr. Minnick. Have a great day. If you have questions, please, please, please ask. See you. Good.